I'm James Johnston, Manager of Training and Support at Microsurvey. I'm happy to talk to you about some of the capabilities of embeddedCAD and in CAD for helping you to solve cadastral problems. The Microsurvey COGO and survey database points functions are core features, and they're integrated into an Autodesk licensed CAD engine. They allow surveyors to define points and thus define boundaries by interacting with points, computations, and field measurements. Direction input is always in standard surveyors units, and they're much more efficient than manual input when you're using standard CAD options. Smart entities, which I'll show you some examples of, ensure that projects can be updated as the field work continues or as changes are made. I'll show you a few examples of features that make this such an efficient tool for solving cadastral problems. I'm using embeddedCAD for this demonstration, but the functions are almost exactly the same within CAD. The difference being embeddedCAD is a single installation, and Microsurvey will license an AutoCAD OEM CAD engine and add their functions to it, whereas in CAD you need to own your own Autodesk product, such as Civil 3D or AutoCAD, and you can, with a separate installation, add all of the Microsurvey functions to it. In this sample drawing here, I've got a grab bag of different features, and I'll give you a little bit of a tour. So first topic is COGO, and this is a function that you're going to find over here. Normally you launch it right from there. COGO allows you to input all of your variables in the command line, and it's just designed to absolutely minimize the number of times that you have to use a mouse or the number of keystrokes that you need to take. It's you'll find it's highly efficient. And before I start doing a little demonstration of a COGO operation, what I'll do is I'll draw your attention to here. We've got a feature called hot toggles, and it is meant to be interacted with while you're performing COGO. And in this case, what I'm going to do is turn on these options here to tell the program that as I compute points, I'd also like to draw lines or curves, and I'd like to plot distance and bearing labels as I work. And another thing that I like to do is I'm going to be performing a computation with this lot here, and I'll be deriving directions and distances from points that are already in the database. And we've got plotted labels, but you'll find as you're working that it's much more convenient to turn on the independent point numbers, and those will give you some floating point numbers that are easier to see at any zoom level. So here I can actually see them even better here. So let me now activate the COGO command. So I can do that here, or I could just type COGO in the command line and just watch down in the command line as I work. And so what I'd like to do is I'm going to input some traverse information in order to compute a point over here at the same direction and distance as that lot line. And then I'm going to do an intersection to compute a point up here. So let's start by computing from point 55. I hit enter. I would like to derive a direction from 54 to 55. So I just type in the point numbers. Same thing with the distance, 54 to 55. Ask me for the new point number I'm going to create, 140. I'll hit enter, and I won't give it a description. And I'll hit enter one more time, and you notice how because this is on, it has plotted a label as well as plotted a line. Now, I'd like to perform an intersection. I'm still in the COGO mode, so I can just continue working. I'll work from 140. I would like to derive a distance from this line here, and so I'll just type in the point numbers, 55 to 57. And then I don't know what the distance is, so I hit enter. Then it'll ask me what's the new point I want to compute, and sure, let's create a point 141. Then it asks for another quadrant bearing, and in this case I want to use this direction here, so I'll type in 51 to 57. Then as a final step, it asks for what's the 2 point, and that's the second known point that we want to compute that intersection from. So that's this point here, 57. I'll type that one in. We hit enter. I don't need a description, and now it automatically plots the lines and the labels. There, I've created that new lot. Now, as I've been going, you've seen how I'm using hot toggles to automatically plot bearings and labels. And I'm going to talk a little bit more about the annotation functions. You'll find the MS Annotate ribbon allows you to access most of the annotation functions. So it's good to take advantage of these automatically plotted labels. But when you get closer to a finished product, then you're going to start wanting to clean up your CAD drawing and use a variety of other tools that you've got for labeling. So I'll show you how I could do a manual line label, and I think for an example what I'll do is I'll zoom in here on this building because later on we're going to do a computation with it. So let me add an auto bearing label to that house line. Pick on the line, hit enter, and there's the label is computed and plotted for me, and it's also associated with this line, as you'll see later on. And so you've got lots of tools in here for different types of line labels. So you've got arc labels and leaders and so forth. And another very popular section, you've got tools that'll allow you to make tables. And so if we back up here, I've actually given you a few samples. Here's a sample of a table that shows us the dimensions for these 4 lot lines. Or up here, I've got an arc table where I picked a selection of arcs or curves from the drawing, and here we've got the information plotted here, and you'll find that there's a label in the drawing identifying the arc that was chosen. And you'll also notice how in this drawing we've got kind of like a variety of different styles, and I've done that just to demonstrate how. Let me go over here to where we can customize our annotation settings. Here you can set up the product so that it will plot your bearing and your distance labels and your curve labels and so forth according to your preferences. So in this example you can see I've assigned style number 1 is set to a particular style name, or that would be a text style name. That would be a layer that gets created when the label is being plotted. You can control what the color is, you can control the font that is plotted, and various other options here as well about how to space out your text and just to control the appearance of it. And you'll also see, if we look at distances, for example, you can assign a scale factor, and that could be a different scale factor with different styles, and you can assign suffixes or prefixes. And so you will also have noticed that you've actually got 5 different styles to choose from. If I pick on different styles, I can see I've got noticeably different styles that you can choose from, and then as you perform labeling, it applies those styles. And whenever you've got a variety of scale factors, this will pop up just to make sure that you're not causing any issues. And what you'll see here in the drawing is I've actually used a number of different styles. So the majority of the drawing was done using the standard style number 1, but here's another style where a suffix has been added and a different font has been used. And over here, if I zoom in on this polyline, we've got a different style again, where there's a suffix and a different line type is used. And another style here. The only thing that's special about it is it has a different text offset to leave room for this thick polyline. And just one more style in here. You can see there's a different suffix that's been used for all of these radial labels. So those are some of the things that you can do to customize the appearance of the labels. Now, I'd like to also talk about the behavior of CAD functions versus survey computation functions. So I'll turn off the IPNs to try and declutter things. And so I'd like to point out that you get sort of different behaviors when you pick on elements, either single click or double click. So if I want Microsurvey to behave essentially like a CAD program, if I single click on any entity, then the standard CAD grips come up, and those allow you to manipulate options as if they were just standard CAD entities. And of course, that's something that you're most likely to want to do when you're at the drawing cleanup stage, where you want to be able to manipulate text and arrows and just tidy things up. And so I can do that with lines and with arcs, and I'm hitting escape to clear them, or with I've got polylines here. All these things, they behave exactly like the AutoCAD program that's in the background. But if I want to manipulate the data as a surveyor does, if I double click on a line, then you get something different. You get what's called the CAD lines computations dialog. And you'll notice how what this does is this gives you information about the points which were used to compute this line. You've got information that are relevant to surveyors, such as direction in surveyors units, and you can get slope distances, you can get grade, you can get a scaled distance versus a unscaled distance. And so that's what you'll get from a line. Or if I pick on an arc, then I get a different, I've got to double click on that arc, and then you get a different style of dialog that also gives you the connectivity information, the relevant curve information, and over here you notice you can actually launch some different computation tools as well. And just one further example, here I've got a polyline. So if I double click on my polyline, here we have the CAD polyline computations dialog, and this actually allows you to review, again, information relevant to surveyors, where you can see information about the different points in the polyline, and you can also look at the individual vertices that make up that polyline. So always good to think about, do I want the program to behave as a survey program or a CAD program? And that allows you to decide between single click and double click. And it would be good for me to just point on one of the point entities as well. Notice how this brings up information about the point editing dialog, and I can even activate the active coordinate editor here, which gives you a full listing of all the points in the drawing. And now that I've got this coordinate editor open, what I'd like to do is give you a little bit of a tour of some of the points computation capabilities that Microsurvey has. And you'll find most of these points computation tools are on the MS Points ribbon, and many of them you'll be able to access right here from the coordinate table, and I'll use that as a little demonstration here. What I'd like to do is, just to help you to understand what you can do, is if you have a look at this house here, I'd like to rotate this house around that point, and I'd like to make it so that this wall is parallel to this lot line. And that's easy enough to do from the active coordinate editor. So what I'd first like to do is select all the points that I want to do computations with. So I can go to select my window crossing, and then in this case I'm just doing a lasso, but here I'll do a window as well. I think I'm just missing that one there. And as soon as I hit enter, then as I scroll through coordinate editor, we can see that all the points have been highlighted in the coordinate editor, and you can see they've got that yellow X on them as well to indicate where they are. And so now I've selected my points. Next thing I'd like to do is perform a computation. Under the Edit menu, you'll find that there's a number of point computation tools, and the one I want to use is the Rotate Shift Scale Selection tool. So this will prompt me to make a decision about whether I want to do it in the command line or a dialog, and I definitely like using a dialog. So I'll go in here and I'll say no to the command line, and here's the dialog. So the dialog's already got all of my points identified up here. This is something that you can edit if you need to. I'd also like to identify my rotation base point, and so that'll be this point here that I want to select, and I think that one, that's actually this point here, this 10,000. So I will tell it, no, I don't want a coordinate. I want to identify a point number, and I'll just type in 10. And you always hit update so that it will pull the coordinates out of the drawing into here. And the other thing that I want to do is set my rotation. So here, there's a number of ways of computing what the rotation value will be, but in this case, I'll just use the 2 lines option. That allows me to go pick 2 lines. I can pick one line, pick the other line, and it's automatically computed what the rotation would be. When it's all finished, I hit process, and I can approve. And now point protection is coming up, and this will always pop up whenever you've got a change in your points database, and we always recommend keeping it on. So I can approve these changes one at a time if I want, or if I turn that off, it will just run through all the changes and the computation happens. And then I'm going to go back to my hot toggles, and I'm going to turn it back on again because I really like point protection. And so what you can see is now that rotation has taken place, the points, the line work, and the labels all updated in the drawing, so it's still accurate and it reflects the contents of the points data. One final type of table that I didn't show you before is you've got the ability to plot a coordinate table out of the active coordinate editor. And I'll do it this way because I also want to show you how Microsurvey interacts with the geodetic database. It's always working in the background. So just for this example, what I'll do is I'll ask Microsurvey to plot or to add addition or information about the coordinates using an alternate coordinate system. So here I'll ask for it to compute what the lat longs would be from my state plane coordinates. So I'll pick on lat long 84, and I'll just add that. And you'll notice how I've already got an Idaho state plane system assigned to this project, and that allows it to compute alternate systems. So as soon as I hit OK here, what we'll see is those additional lat longs are going to be plotted over here as different columns. And what I'd like to do is just show you how I'll set it up so that I'll just plot that range of coordinates in a table. And what I'd also like to do is now I'm just picking on the selection bars at the top of the active coordinate editor. And so I'm just picking the different columns that I'd like to plot in a coordinate table. So I'm doing point ID, northing, easting, the combined scale factor, the convergence angle, and over here let's do latitude and longitude. And so I'll be creating a table consisting only of the items that are overlapping in this selection. So go back to Tools, and we do Table in Drawing from Selection. And so now it's just going to prompt me for a location for that table, and I might as well just put it right there. And it's computed all the values and plotted them right in the drawing. Now, the final thing that I'd like to show you is, because you're working with an Autodesk licensed CAD engine, you can use all existing workflows that are required for computing or for creating a final drawing using a layout. And so we've already got a layout inserted here, and a viewport is set up. That's showing a window into at least a part of the drawing. As you can tell, I'd probably need a bigger piece of paper for this to work. And it'll be important just for me to do a little bit of a comment about scale factor. So if I pick on that viewport and I ask to have a look at its properties, what we're going to see is this viewport has been given the standard scale of 1 to 20. And that's exactly the way we like it to be. And I'll show you why, because if I go to MS Tools and the Job Defaults, which you always see when you open up a drawing, you can see that it's also got a drawing scale factor of 20 assigned to it. And that's the way we want it to be. We would like this number to match the plot scale. The reason for that is you've noticed how I've been doing all this work, how we're automatically creating and inserting labels, which we often refer to as smart labels, and their text height is being computed according to the intended plot scale. So if you've got the a drawing scale factor that matches your plot scale, then you're going to find that the height that you've assigned to that text is going to be exactly the height you see when you finally plot the drawing. So in this case, according to the style, this type of label should have a height of 0.06 inches. You will find that when you plot it, it'll be 0.06 inches. And that setting also affects other things such as blocks and other types of text. That's all that I wanted to tell you about the cadastral abilities of Microsurvey Embedded CAD as well as in CAD. And I thank you for your time, and I hope that I've interested you and given you ideas for a whole bunch more questions. Please do pass those along to your Microsurvey contact. We love to answer questions about this product.